In this video, we're going to continue learning about graph transformations. So in the last video, we looked at single graph transformations. This time we're going to look at graph transformations where there are multiple transformations going on, multiple influences. So we left at the last lesson with a summary of all the different transformations we could have and what influence each of those had on the coordinate points on the graph. So you can see this here, and we'll still be using this even though we might be meeting several graph transformations in the one question. So we'll just go on with an example. So shown is a graph of y equals f of x, and we are asked to sketch the graph of y equals negative f of x minus 2. So firstly we can see that we've got a negative outside here, and we've got inside the bracket, instead of x, we've got x minus 2. So we've got two things going on. We've got multiplication of the function by negative 1, and then instead of x, we've got x minus 2 within the function. So these two things that are going on here, we need to remember our order of operations. So the order that we calculate things in normally, if we were dealing with a numerical example, would be brackets first, then we would have multiplication and division, and then we would have addition and subtraction. So firstly here we do have the brackets, if you like, so we'll deal with this part first, then we've got multiplication outside. So we're going to set up a table, and like I said, we'll start with f of x, and then we're going to look at the brackets first, so it's f of x minus 2, and then we'll look at the multiplication of the negative 1. Now, on the graph of y equals f of x, I have 3 different points here, and I'm going to examine each of these individually. So for f of x minus 2, I know that is a shift of the graph to the right by 2 units. So I'm adding 2 to each of my x ordinates here. So negative 3 add 2 gives me negative 1, 0 as my new point. Next one, negative 2, 10 will become 0, 10. And 1, negative 17 will become 3, negative 17. Now I could draw that graph as it is. You can see same shape and everything, but what's happened is the graph has moved to the right by 2 units. Now, we now have negative f of x minus 2, and the negative is multiplying each of, it's basically resulting in each of my y ordinates being multiplied by negative 1. So negative 1, 0 becomes negative 1, 0, because 0 multiplied by negative 1 still gives me 0. 0, 10 will become 0, negative 10, because I'm multiplying my y ordinate here by negative 1. And finally, 3, negative 17 will become 3, 17. So I can plot those points, and if I think about what this is going to look like, now when I multiply f of x, or f of x minus 2 as this is, by negative 1, it results in a reflection across the x-axis. So I'm keeping the same shape of my curve, but actually it's being reflected, so it's sitting the other way. So you can see that there. And that is our final answer, our final graph. So it's y equals negative f of x minus 2. And just a reminder, we need to go through it in order. We do the brackets first and then the multiplication. You'll notice the bit inside the brackets that had an effect on our x ordinates, and but outside the bracket here, the negative 1, that had an effect on my y ordinates. So just now would be a good time to pause the video and take this down in your notes. Okay, welcome back. We'll have a look at another example here. So shown is a graph of y equals f of x, and we want to sketch the graph of y equals 3f of 2x plus 1. Now, this time you can see that we have 3 different things going on here. we are multiplying by 3. Instead of f of x, we'll get f of 2x, and then we're adding 1 on at the end. Now, like I said in the last example, there's an order that we do things in. So we look at the brackets first, we then look at multiplication and division, and then we look at addition and subtraction. So looking at my table again, I'm going to use my table of points. My brackets first, that's f of 2x. Then multiplication and division, that's multiplying by my 3. And then addition and subtraction, so adding my 1 here. So you can see all the different stages I'm going through. And if we look back at the original graph, y equals f of x, you can see that I have 4 points. So I've got negative 1, 0, 0, 2, 1, 0, and 3, 0. So firstly, f of 2x, that is resulting in horizontal compression. So that means that I am halving all of my x ordinates. So I'm dividing each of my x ordinates by 2, giving me negative a half 0. 0, 2, no change there because it's 0 divided by 2 gives me 0. 1, 0 becomes a half 0, and 3, 0 becomes 3 over 2, 0, or 1 and a half 0. I can draw the graph there, and you can see that the graph has been horizontally compressed, so it almost appears to be thinner, if you like. Now, for the 3f of 2x, I'm multiplying each of my y ordinates by 3, so that gives me negative a half 0 still, 0, 6, half 0, and 3 over 2, 0. There doesn't appear to be a lot of change there because of all the y ordinates are 0 apart from 1. You can see there actually has been a change, so that has resulted in a vertical stretch by 3 units. So you can see the graph almost appears to be taller, if you like. And finally, we are adding 1 at the end here, and that will result in the graph moving up by 1 unit. So I'm adding 1 onto each of my y ordinates, so I'm going to get negative a half 1, 0, 7, a half 1, and 3 over 2, 1. And plotting those points, and the graph hasn't been reflected or anything, so it still has that same shape where it's increasing, has a turning point, and then decreasing, turning point, increasing again. And the same thing is happening there with the final answer. So just now would be a good time to pause the video before the screen goes blank and take this example down in your notes as well.